All right, guys, we're going to go ahead and do some more fractions, but we're going to extend on what we were talking about last time, and we're going to start doing some stuff with some variables in it. So we've got 3 minus x squared over x plus 1, 1 plus x over x squared minus 1. So essentially what I want to call your attention to is we're going to solve this in pieces, okay? Not going to rush out and do anything crazy. We're going to start with our numerator, we're going to work our numerator, and we'll work our denominator and go as such, all right? So first thing I'm going to do is I know I need common denominators. So in order to get our common denominator, I'm going to look, this is a 1 underneath, so I'm going to go x plus 1 as my common denominator. In order to do this, I'm going to multiply x plus 1 times my 3, and I know my 3 is really 3 over 1. Minus. Now since this has the x plus 1 in it already, I don't really have to do anything to it. But we're going to go ahead and we're going to multiply it by 1. And the reason for this is to demonstrate we're keeping the same process as we did over here. But in our case, instead of multiplying by x plus 1 over x plus 1, which is 1, we're just going to go 1 over 1. And we're going to multiply by 1 this way. So we're multiplying by 1 in both cases. The only difference is this one is dressed up as a 1, if you will, and this one is dressed up as an x plus 1 over x plus 1. At this same token, we've got the x squared minus 1. We're going to make that our common denominator. And I'm writing this one as a 1 over 1 in the same manner that I wrote 3 as 3 over 1, just to make sure that we understand we got a numerator and denominator. Let's put this 2 over there. Okay, so we've got that. So from here, we're going to do all our multiplication. This is going to multiply this. This is going to multiply that. And when we get that, we're going to get our 3x plus 3 minus x squared over x plus 1. Now that's going to be divided by our x squared minus 1, x squared minus 1 minus our x. So x squared minus 1 minus our x over x squared minus 1. Okay, so now we remember that we're going to have we have a fraction within the fraction, so we're going to take our denominator, we're going to use a reciprocal, and we're going to get multiplication. Now I'm just going to rewrite this. I'm going to put the negative x out front. It's not that big of a deal. We're just making it a little pretty. So again, we multiply, and now I'm going to use my reciprocal. And from here, I'm going to go ahead and rewrite this as x squared minus 1 minus x to x squared minus x minus 1. All right. Now, at this point, I'm going to go ahead and get our x plus 1, our x minus 1, over our x squared minus x minus 1. So from here, I'm factoring this out, the x squared minus 1, noting it's perfect squares with my two numbers, my variable here, my number there. If you don't know the factoring, make sure you handle that up. Now, I reduce this to 1. I reduce this to 1. So I'm left with this times that. So I'm left with x minus 1 times my negative x squared plus 3x plus 3. And I'm really hoping you can see this up here as part of the video, over our x squared minus x minus 1. Okay? Good to go? All right, such that, of course, we don't want our x squared minus x minus 1 being equal to 0, because in any fraction, we know that our denominator should not have a 0. Okay. Going to take a second to erase. Okay, so for this one, we're going to go ahead and we're going to add these two, or excuse me, find the difference of these two fractions. Note that they do not have common denominators. So we're going to find out exactly what denominators we need. And the way we're going to do that is we're going to factor down our two denominators and find out what our lowest common denominator is going to be. So this is an x plus 2 and x minus 2. Minus 2 over x plus 3, x minus 2, right? All right, now here's the deal. I have a negative 2 and a positive 2. I have a negative 2 and a positive 3 going with my x's here. So what I don't have in this one is an x plus 3. What I don't have in this one is an x plus 2. So what I'm going to do is I'm going to act accordingly. I'm going to multiply this out. So x plus 3 over x plus 3 times 4x minus 2 x plus 2 minus x plus 2 over x plus 2 times my 2 over x plus 3, x minus 2. All right, so this is what I'm looking at. This has got a x plus 3, x minus 2, x plus 2. Here's my x plus 3, x plus 2, x minus 2. Remember, multiplication is commutative, so we don't worry about the order. We just make sure that we have all three of them. So now we got a lowest common denominator. So at this point, multiply this out. I have 4x plus 12 minus, and I'm gonna write it this way. You don't really have to, but I'm gonna write it this way as I distribute out my 2. I'm gonna leave it in here so we don't forget this negative sign, okay? So I'm multiplying these two together, but I'm not gonna forget this negative sign. I'm leaving it there. And I'm just gonna put this over our lowest common denominator. So this is going to be 4x plus 12 minus 2x minus my 4 over my lowest common denominator. All right? So now, we combine these up, I get 4x minus 2x plus 12 minus 4 over my lowest common denominator, which is 2x plus 8 over my x plus 3, my x plus 2, and my x minus 2. Now, at this point, I can look at this and I can say, hey, you know what? Let's go ahead and break it down. I got a 2 in common here. I might get lucky and be able to reduce something out. So if I choose to do that, okay, so notice that I am not able to reduce. Now, we're not done yet. I want to call your attention to the x plus 3, the x minus 2, and the x plus 2. Sorry, x plus 2, x minus 2. So what we're going to do is we're going to set our denominators to 0. I touched on this before. We're going to go ahead and just do this one now. So I know that x plus 3 is equal to 0. I can go x plus 2 is equal to 0, or x minus 2 is equal to 0. Now essentially what I'm doing is I'm saying this times this times this. If any one of those are 0, then this whole thing's going to 0. So this is 0, or this is 0, or this is 0. So I set each binomial up to say it's equal to 0. I subtract 3 from both sides. X is negative 3. Subtract 2 from both sides. X is equal to negative 2. And I add 2 to both sides. So I say x is 2. So basically I have this is my answer here. However, I'm going to say such that x cannot be equal to negative 2 or positive 2 or negative 3. Okay? And if I really want to be a little nice about it, I'll put it a negative 3 over here, just so that way we're a little in order. Okay? So I personally, I would take it in this form. I would take it in this form. However, I do want you to remember to get these in. All right. All right, so we're going to get multiplication. If I really want to, I could just straight out go through and multiply, FOIL it out, you know, get the muscles going and do that. But I'm not going to. I'm going to go ahead and reduce some because there's a few things that are jumping out to me. So I'm going to pull this 3 out, and when I do, this becomes x minus 2. Here's my 5x times x minus 3, x plus 2. This is going to be my x2, x minus 2. Right? All right. Well, this is multiplication. We know multiplication is commutative, right? So I can reduce up and down. I can also cross reduce. So this x minus 2 is going to reduce this x minus 2. This x plus 2 is going to reduce this x plus 2. So I'm left with 3 times x minus 3 over, there's my 5x, such that x is not equal to 0. Just like that. All right, now, again, I could have taken this and did the FOIL thing where we went 3x times x squared, 3x times negative x, 3x times negative 6, so on and so forth, and put them together, reduce them, so on and so forth. We don't really want to do that when we could just make life easier by noticing that this and this and this can all be factored out, okay? Remember, Dr. George Roberts said, never solve a problem spontaneously. Just because you can multiply doesn't mean you should. You know, take your time about it, look at what you have, and then see how you want to attack the problem. Until next time.